you did cover measurements 1 somewhere, and we actually measurements 1 was I think the second topic in Form 1 work. So in case you did not understand it well, you can just review the clip on measurements 1. So actually in measurements 2, so in measurement 1, actually the basic instrument for measuring length was the meter rule. So but in this chapter, that is in measurements 2, measurement of length such as the diameter of a wire and that of a test tube, which cannot be obtained directly using an ordinary meter rule, are done using what we call the calipers and also what we call the micrometer screw gauge. Now basically we have two types of calipers. One, we have what we call the engineer's calipers, and two, we have what we call the vernier calipers. So let's start by discussing the engineer's calipers. So engineer's calipers, this is how they look like. So the word engineer's calipers, it means these are the calipers that are mostly used by engineers. Remember, engineering applies a lot of physics. So actually this figure here, it shows engineer's calipers used for measuring distances on solid objects where an ordinary meter rule cannot be used directly. So engineer's calipers consist of a pair of hinged steel jaws. So this is where we have the hinge. Hinge means that actually this part is movable. That is, the calipers can be adjusted in such a way that they can one part can measure the outside, can be applied as the outside calipers, then the other side can be applied as the inside calipers. So it consists of a pair of hinged steel jaws which are closed until they touch the object in the desired position. So the diameter of round objects can be measured using outside and inside calipers as shown here. Then we are saying that one kind is changed to the other by turning the jaws completely. So if these jaws can be turned in such a way that this actually this part can be used, can appear this way, so this other part so if you turn this jaws such that this one they hold closer to each other, then actually this other jaws will open up and it will appear in this manner. So you just, when you adjust it until it touches exactly the outside part of the object whose length is actually to be determined, or whose diameter is to be determined. So because this part here, it measures the outside diameter of objects, so outside, so hence the word outside calipers. Then this part, if adjusted, that is, if you close this other part, actually this, the upper part here will appear in this manner. So you adjust them such that they just touch the inside of the object whose diameter is to be determined. So because they measure the inner diameter of the objects, hence the word inner calipers. Therefore they are called inner calipers. So when using the calipers, the jaws are opened just to slip past the cylinder or the wide part of the sphere. Then the distance between the jaws is then transferred and read on an ordinary millimeter scale. So after you've obtained, that is after you have adjusted the caliper such that they just touch the outside parts of the object whose length is to be measured, then you transfer exactly the same distance on a millimeter actually scale. So if you transfer it on ordinary millimeter scale, so the distance from this jaw of the caliper to this other jaw of the caliper, that is distance x here, that will represent the diameter of the outside diameter of this particular cylinder here. Also, if you transfer this caliper, that is the inside calipers, you just transfer it, you carry it and transfer it on a millimeter scale, then you obtain the distance from here to here. So that distance between the jaws of the caliper represents the inside diameter of that particular object. It represents the inside diameter of that object. So basically those are the that is the first type of calipers, what we call the engineer's calipers, and we've also discussed how it actually works. We look at the other type of calipers, what we call the vernier caliper. We have what we call the vernier caliper. So these are actually the features of a vernier caliper. We have the inside jaws, inside jaws, because these ones can be used to measure the inside diameter of a given particular cylindrical object. So they are called inside caliper jaws because they clip, that is the inside part of the particular object or even a cylinder, and when then of course it has its own scale where the readings can be taken. So we'll see how. Then it also has what we call the outside jaws. The outside jaws, because in this case, if you want to measure the outside diameter of an object, you just place the object in between this, the fixed jaw and the sliding jaw. Then you adjust, of course, the sliding jaw such that it exactly fits on the outer part of the object. Then, of course, the reading is taken. So this one is the fixed jaw. Fixed means it does not move. So this part is not movable. So that's why it is called the fixed jaw. It is a jaw that never moves. But this one is called a sliding jaw because it can actually be slided over this particular, what we are calling the main scale. So this actually part, this jaw is movable. That is, it is adjustable. It can be moved maybe closer or even outward, depending with the size of the object to be, whose diameter is to be determined. Then a vernier caliper has two scales. One, we have what we call the main scale. So the main scale is running from 0, then 1, 2, it continues from here, 3, 4, then 5, 6. So this is what we are calling the main scale. Then it also has a smaller scale which we are calling the vernier scale. So a vernier caliper has two scales. One is the main scale, and also we have what we call the vernier scale. So that gives you a hint that whenever we are making measurements using a vernier calipers, we have to obtain measurements of the main scale reading and also the measurements of the vernier scale reading. Then of course we sum the two, or we add those particular two. So you can be drawn this particular diagram, then you can be asked to name the parts of the vernier caliper. So these ones, we call them the inside jaws because they can be used to measure the inside diameter of object. That is, the object is just placed in between here, then the sliding jaw of course is adjusted such that this part touches the one inside part of the object to be measured. Then this other part, it also touches the other side of the object to be measured. Then of course that length, its length is read from the two scales. That is the main scale reading and the vernier scale reading. Then you have said these ones are called the outside jaws because they can be used to measure the outside length of a particular cylindrical object, or even any circular object or spherical. So in vernier calipers we have something we call the least count. So the vernier scale has 10 equal divisions. This is what we are calling the vernier scale. So you can see it is running from 0 up to 10. So the vernier scale has 10 equal divisions. Then the length of the vernier scale, that is the distance from here, from the 0 mark of the vernier scale up to the 10th mark of the vernier scale. If you measure this distance using a meter rule, it is always obtained to be 0.9 centimeters. So we are saying that the vernier scale has 10 equal divisions. That is the first, the second, the third, the fourth, the fifth, the seventh, the eighth, the ninth, and the 10th division. So the vernier scale has 10 equal divisions. Then the length of the vernier scale is 0.9 centimeters. That is the distance from here, from the 0 mark up to the 10th mark. If you measure that distance using a meter rule, you will obtain it to be 0.9 centimeter. So that means that each division of the vernier scale will actually be, so if the distance from the 0 mark up to 10 is actually 0.9 centimeter, then this scale has 10 divisions. If you want to obtain the distance of each division, it will actually be, you will take the total length of the vernier scale divided by the number of divisions. So that will give you the length of each division. That is the length of one of the divisions of this vernier scale. So we have said that the length from the 0 mark up to 10th mark, if you measure using a meter rule or any other relevant measuring instrument, it is obtained to be 0.9 centimeter. Then the vernier scale has 10 equal divisions. So that means each division of the vernier scale will be given by 0.9 centimeter divided by the number of divisions, which are 10. So if you take 0.9, you divide by 10, you will get 0.09. So 0.09, that is what we are calling the length of the vernier scale division, the length of the vernier scale division. So each division of the vernier scale is equivalent to 0.09 0.09 centimeter. So we are saying the 0.09 centimeter is coming because the total length of the vernier scale is 0.9 centimeter. Then the vernier scale has 10 equal divisions. So the length of each division would be 0.9 centimeter divided by 10 divisions. So that gives you the length of each division as 0.09 centimeters. Then the main scale, that is the division of each main scale. Remember, if you are talking of a division, you are talking of like this one alone. So if from here to here is 1 centimeter, then then from the 0 centimeter mark up to 1 centimeter mark, we have actually 10 divisions. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. So that means if you want to find the length of each division of the main scale reading, you will actually take the total length, that is from 0 up to 1 centimeter, divided by the number of divisions, that is from 0 up to 1. So the number of divisions from 0 up to 1 centimeter, they are actually 10 divisions. So if you take 1 centimeter divided by 10 divisions, you will obtain 0.1 centimeter. So 0.1 centimeter, that is the length of the main scale division. That is, each main scale division, it has a length of 0.1 centimeter. So if you subtract 0.1 centimeter with 0.09 centimeter, you will actually obtain 0.01 centimeter. So this 0.01 centimeter is what we are calling the least count. So in short, we are saying that, so remember, if you are talking of minus in mathematics, minus simply means what? The difference. So in short, we are defining the least count as simply the difference in length between the main scale division and the vernier scale division. The difference in length, that is, difference means we are subtracting. So if you take the length of each division of the main scale, you subtract the length of each division of the vernier scale, it gives you 0.01 centimeter. So this 0.01 centimeter, this is what we are calling the least count. So if you are asked to define the term least count for a vernier caliper, you simply say that the least count is the difference in length between the main scale division and the vernier scale division. So we are saying that least count is the difference in length between the main scale division and the vernier scale division. So for a vernier caliper, the least count will always be 0.01 centimeter. So the least count is 0.01 centimeter for a vernier caliper, and you are saying that the least count is the difference in length between the main scale division and the vernier scale division. Then the object whose length is to be measured is placed between the outside jaws. So if you want to measure the outside diameter of a given object, maybe, or any other object, for example, you can talk of a marble. In most cases, we measure it using a circular object. For example, you can talk of a marble, or even some spherical objects, for example a small ball, or any other spherical object. So remember, we also have in the modern days, we also have what we call the digital vernier calipers. The digital simply means that instead of reading the scales, instead of reading these divisions, it displays the measurement in digit form. That is maybe 1.4 centimeter or 10.5 centimeter. So because it gives it in terms of digits, hence we call it a digital vernier caliper. So we have other types of calipers which we call the digital calipers. So to measure the length of an object using a vernier caliper, the object whose length is to be measured is first placed between the outside jaws. So you simply place the object between these outside jaws. Then after placing the object between the outside jaws, you slide or you move the sliding jaw. You move the sliding jaw closer to the object such that it touches exactly the outside parts of that particular object. Then of course you take the readings. So for a vernier caliper, the reading is taken in two steps. So the first step, we take the reading of the main scale division. Then the second step, we take the reading of the vernier scale division. Now, how do we take the main scale reading? That is the reading of the main scale division. So in taking the reading of the main scale, we simply, for the main scale, we record the reading on the main scale opposite and to the left of the zero mark of the Vernier scale. So this is what we mean. If this is our Vernier scale, because this is our Vernier scale, if you want to obtain the reading, for example, for this particular case, assuming you have an object here, actually for this case the main scale reading will be 3 centimeters. Why? For the main scale reading, you record the reading on the main scale. Remember, this is the main scale, 0, 1, 2, 3, 4, 5, 6. This is the main scale. You record the reading on the main scale, which is opposite and to the left of the 0 mark of the Vernier scale. So this is the 0 mark of the Vernier scale. So you record a reading on the main scale which is opposite and to the left. So if this is the 0 mark of the Vernier scale, the left hand side of the Vernier scale is actually this side, because this other side will be the right hand side. So you record the reading on the main scale which is opposite and to the left. Opposite means it has to be directly above, somehow directly above, which is opposite and to the left of the 0 mark of the Vernier scale. So this the immediately the left hand side. So from the 0 mark, the left hand side, you actually get to 3. So in this case, the main scale reading will actually be 3. So we are saying that for the main scale reading, you record the reading on the main scale which is opposite and to the left of the 0 mark of the Vernier scale. Then how do we obtain the reading on the Vernier scale? So on the Vernier scale, you record the Vernier scale mark that coincides exactly with a main scale marker. Then you multiply times the least count. So this is what we mean. If this is our Vernier scale, you look for a mark which coincides. To coincide is to align, to exactly align with another mark on the main scale. So like for my case here, the first mark here, I can see it is not well aligned. I think for this case, this is the mark that is exactly aligned with another mark on the main scale. To align means it is exactly along the same line. Like you can see actually these particular divisions. So for this case, we say they are coinciding. So if this is the 9th mark, if this is 0, that is 1, 2, 3, 4, 5, 6, 7, 8. So the 8th mark is the one that is exactly coinciding with a mark on the main scale. So because that is 9, no, that is the 8th mark, then you multiply by the least count. We just say that the least count for a Vernier caliper is 0.01 centimeter. So you take 8 times 0.01, you obtain 0.08 centimeter. So the Vernier scale reading for that case will be 0.08 centimeter. Then if you want to obtain the total reading of the Vernier caliper, you now take the main scale reading plus the Vernier scale reading. Like for this case, it will be 3 centimeter plus 0.08 centimeter, which comes approximately to 3.08 centimeter. So it is also worthwhile noting that for Vernier calipers, measurements are always taken in centimeters. So Vernier scale, the Vernier calipers, in Vernier calipers, measurements are always taken in centimeters. So we are saying that the reading for a Vernier caliper is taken in 2 steps. One, the first step is you obtain the main scale reading. The main scale reading is obtained by you record the reading on the main scale, which is opposite and to the left of the 0 mark of the Vernier scale. You just look at the 0 mark of the Vernier scale, then you look at a mark that is coming exactly opposite and to the left of the 0 mark of the Vernier scale. So you look at a mark on the main scale. Like for this case, if this is my 0 centimeter of the 0 mark of the Vernier scale, then I just look on the main scale, a mark which is coming to the left, opposite and to the left. So like for this case, it is actually the 3 centimeter. So the main scale reading will be 3 centimeters. So for the main scale, you record the reading on the main scale, which is opposite and to the left of the 0 mark of the Vernier scale. Then for the Vernier scale reading, we've said you record the reading, you record the Vernier scale mark that coincides or aligns exactly with the main scale mark. Then you multiply that by 0.01, which is actually the least count. Then example involving how to record a reading using the Vernier calipers. So an example reads, record the reading indicated by the scales of the Vernier calipers below. So remember, if you are given these 2 scales, the upper scale, or the scale that runs from maybe 1 up to other marks. It can even go up to 10 or even in some cases 15. That is what we call the main scale. So like for this case, this will be the main scale. Then remember, the vernier scale always runs from 0 actually up to 10. Remember, in some cases they will not tell you which one is the main scale and which one is the vernier scale, but it is up to you to know that the vernier scale always runs from 0 to 10. Then the main scale actually runs to up to any other values, up to any other relevant values. It can even go beyond 10, but the vernier scale will always run from 0 to 10. So in this case, we are required to record the reading indicated by the scales of the vernier calipers. So we've just said that for the case of a vernier caliper, readings are recorded in two ways. One, you record the main scale reading, then also the vernier scale reading. Then you sum those two to obtain actually the actual reading or the actual diameter of the object. So we did say that, so let's start reading. So the first reading, we obtain the reading of the main scale reading. So for the main scale, we have said that if you want to record the reading of the main scale, you record the reading on the main scale which is opposite and to the left of the 0 mark of the vernier scale. So like for this case, this is our vernier scale. This is the 0 mark of the vernier scale. So you record a mark on the main scale that is exactly opposite and to the left of the 0 mark of the vernier scale. So if this is my 0 mark of the vernier scale, so I look at a reading which is opposite and to the left of the 0 mark of the vernier scale. That is a mark which is on the main scale. So like for this case, if this is my 0 mark of the vernier scale, I'm reading a value that is opposite and to the left. This is the left hand side. So a mark that comes immediately to the left hand of the 0 mark of the vernier scale, that is on the main scale, that is what will be the main scale reading. So like for this case, my main scale reading will be actually this division here. Again, from here up to here, this is 2, then that is 10. Then if you count these divisions, you will find there are 10 divisions. So that means that each division represents 0.1. So if this is 2, then this is 2.1, this is 2.2, this is 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, then 3. So that means a mark that is exactly on the left of the 0 mark of the vernier scale, for my case here, is 2.1, 2.2, 2.2. So my main scale reading will actually be 2.2 centimeters. Then we've said that for a vernier caliper, the readings are always recorded in centimeters. So whether they have told you in centimeters or they have not told you, as long as you are dealing with a vernier caliper, always know that the readings should always be recorded in centimeters. So this is 2.1, 2.2. So that's why you are seeing my main scale reading here is actually 2.2 centimeters. Then for vernier scale reading, we said to obtain a reading on the vernier scale, you read the vernier scale mark that coincides or aligns exactly with main scale mark, then you multiply that by the least count. So if I look at my divisions on the vernier scale here, I'm looking for a division that aligns or coincides with another mark on the main scale. Then I will multiply that particular mark times the least count. So in this case, we have the 0 centimeter mark is not aligning with any other mark on the main scale. The 1 centimeter is not aligning with any mark. The 2 centimeter not aligning. The 3 centimeter not aligning. The 4 centimeter is actually aligning or it is coinciding with a mark. To coincide means that they lie in the same line, as you can see here. Actually, these divisions, you can just think it is one. They are coinciding or they are exactly aligning. So you look for a division on the vernier scale which exactly coincides with a mark on the main scale. So like for my case here, if this is 0, then this is 5, then that is 10. So it means each division is actually 1 centimeter. So if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the fourth mark is the one that is coinciding or aligning with the mark on the main scale. So I will take that 4. So because it is the fourth mark which is coinciding or aligning, you take that 4, the vernier scale reading, you will take that 4, then you multiply by the least count. Remember, we just said that the least count is the difference in length between the main scale division and the vernier scale division. That is for the case of a vernier caliper. So you take that mark which is aligning, that is the fourth mark, then you multiply by the least count for a vernier caliper, which is 0.01 centimeter. So you multiply 4 times 0.01 centimeter, you will actually obtain 0.04 centimeter. Then after that you sum or you add the main scale reading plus the vernier scale reading, so that gives you the vernier caliper's reading or the length of the object. So you take 2.2 centimeter plus 0.04 centimeter, you add those two, you will actually get 2.24 centimeter. So this will be the reading of the object or the vernier caliper reading. So you just take the sum of the main scale reading plus the vernier scale reading times the least count. Then when you add the two, you actually get the reading of the object. So B here, part B here, this is an assignment. I want to see whether you've understood how we've been obtaining this particular marks here. So this is an assignment. This our the vernier scale reading and the main scale reading. So you obtain the reading indicated by this scale. So the expected answer is 7.09 centimeter. So actually try using the same procedure that we have used in A here. Try applying the same procedure on this part B. You see whether you actually get 7.09 centimeter. So if you get this particular answer, actually it means you have understood our part A here, and that always feels good to me because it means that I'm doing something constructive. Then we have said that reading of a vernier caliper are always taken in what? In centimeters. Lastly, we look at what we call the zero error. Remember, there is a question that is usually asked. You can be asked to state any two types of errors in measurements. Remember in measurement 1, that is in Form 1 work, we did talk of an error which comes as a result of not reading the scale at perpendicular. So that error we called it the parallax error. Then we are also introducing another error in measurement which we are calling the zero error. So if you are asked to state two errors in physics and how they can be corrected, the two errors in measurement are actually the parallax error and zero error. So the two errors in measurements in physics, we have what we call the parallax error, and two, we have what we call the zero error. So what is the zero error? So when the jaws of a vernier caliper are closed without an object between them, the zero mark of the main scale should coincide or align with the zero mark of the vernier scale. However, this is not always the case. That is, if a vernier caliper is actually correct, if it is the accurate one, if the jaws are closed, when the jaws are closed, it means there is no object between those particular jaws. If the jaws are closed, the zero mark of the main scale should align or coincide with the zero mark of the vernier scale. However, this is not always the case, meaning that we have some vernier calipers which could actually be faulty, or they have they are not correct. That is, they have some certain error which we are calling the zero error. So we have two types of zero errors. We have what we call the positive zero error and the negative zero error. So if the zero mark of the main scale is to the right of the zero mark of the vernier scale, that is as shown here. If this is our vernier scale, the smaller scale, then this is our main scale. So if the jaws of a vernier caliper are closed, that is with no object within them, then you realize that the zero mark of the main scale is to the right hand side of the zero mark of the vernier scale. That is as shown here. The zero mark of the main scale is on the right hand side of the zero mark of the vernier scale. Then we say that such a vernier caliper, it has an error, what we are calling a negative zero error. So if the zero mark of the main scale is to the right of the zero mark of the vernier scale, then there is a negative zero error. Then how do we correct a negative zero error? So because it is a negative zero error, we correct it by adding the equal number of error that has been caused. So a negative zero error is corrected by adding the zero error to the reading. By adding the zero error to the reading, we look at an example down there. Then we have another error we are calling the positive zero error. The positive zero error. Like for this case, let's look at the zero error. Like for this case,